Hi, and welcome to our discussion on synoptic scale weather features. We already did fronts and vertical cross sections. We're ready to work our way into jet streams. And first, best way to get started is to define jet streams. And a jet stream is actually just a narrow channel of winds moving very quickly, high-speed winds. And jet streams can happen anywhere in the atmosphere. They can happen down at low levels. As a matter of fact, during the summertime, there's a low-level jet stream that usually kicks in across the central plains of the United States. But in synoptic meteorology, we're going to spend our time looking at high-altitude jet streams, typically found right near the tropopause. There are certain features of the jet stream that are interesting to us. One of them is the jet core. The jet core is the three-dimensional representation of the winds in the jet stream, the center or the fastest moving winds. So there's no real way of defining that, just where you see the center moving along a little bit faster. It's three-dimensional, so it's not only looking at a weather chart, but also looking at cross-section, trying to put those two together, trying to visualize where the jet core is. The jet axis is a little bit different than the jet core. The axis is the center of the jet stream, but it's connecting, if you look at a constant pressure chart, if you connect all the points with the strongest winds, that would represent the jet axis. In other words, it's a line that represents the center of the jet stream. It's where you have the maximum winds on a constant pressure chart, and it's where the jet core actually intersects on a constant pressure chart. So in other words, you're looking at a two-dimensional representation of the jet stream. So here's an example of a jet axis. All it's done here is on a 300 millibar map connect the points of the strongest wind speed. And you can see in this case, the jet axis is split across Montana and North Dakota and kind of finally meets up together across the Great Lakes and then moves across the east coast of the United States. So the jet stream, there are a lot of different types of jet streams, as I mentioned, but for synoptic meteorology, we're going to focus on the polar front jet stream and the subtropical jet stream. This picture shows you the subtropical jet stream is found at a lower latitude and a higher altitude. The polar jet stream is found farther north, so that's a higher latitude, but a lower altitude. So the polar jet stream moves, of course, across the entire world. It's kind of connected with stronger winds represented by jet streaks that move through the jet stream. Generally speaking, the polar front jet stream separates the cold air from the cold air up in the Arctics from the warm air down in the tropical locations. And then the subtropical jet stream is found in a much lower latitude. The subtropical jet stream typically are between 25 to 35 degrees north latitude, higher than the polar jet stream, as we mentioned. Usually the subtropical is up about 200 millibars or about 40,000 feet. So if you're looking for the polar or the subtropical jet stream, you got to look at the 200 millibar map. And as the diagram shows or picture shows, it tends to be stronger across continents than it is across the oceans. Actually, the polar jet stream, or the subtropical jet stream was discovered by B-29 bombers flying to Japan during World War II. Here are some characteristics of the subtropical jet stream. It's about 10,000 feet deep, and usually it's a little bit stronger in the winter than in the summertime. Its strength varies anywhere from 125 knots and all the way up to 250 knots. And the reason the subtropical jet stream exists is because of the conservation of angular momentum. In other words, as you move farther north, remember that there's a Hadley cell in the tropics, and as the air rises in the upper levels of the atmosphere, it moves northwards towards the pole, from the equator to the pole. So as it does that, notice that the radius of the Earth along its axis of rotation is decreasing. So that means that the angular momentum is decreasing So the jet stream has to move towards the east to compensate for that. So in other words, you get a jet stream because of the reduced angular rotation of the Earth as you move farther north. Polar jet stream is a little bit different, though. Polar jet stream is found at farther northern latitudes, anywhere from 30 to 6 degrees north. Of course, we talked about how it separates the cold air from the warm air. You can see, looking down on the North Pole, you can see the polar vortex showing up pretty well. And the polar vortex is what is one cause of the polar front jet. As we mentioned, it's a little bit lower than the subtropical jet stream, typically about 300 millibars or about 30,000 feet. It's about 200 to 300 miles wide across, and its depth is about 10,000 feet, the same as the subtropical jet stream. Strength varies between 60 and 200 knots, stronger in the wintertime and weaker in the summer. And also the subtropical or the polar front jet stream moves to the south in the wintertime because it's associated with cold fronts and warm fronts. The reason for the polar front jet stream is because of the cold air to the north up in polar locations and the warm air to the south. That causes the pressure surfaces to slope towards the North Pole. Remember, they slope the greatest where you have the greatest temperature gradient. That would be right around the frontal locations. So where you find fronts, you also find strong winds in the upper levels of the atmosphere. Using the thermal wind equation and that concept, that means that you're going to have a stronger wind at altitude because of that strong temperature gradient. That type of jet stream is called the polar front jet stream. And of course, the polar front jet stream you'll find with the polar front. Typically, it's found a little bit to the north of the polar front, the surface position of the polar front. And it's found, the jet stream itself is found right at the tropopause. And remember, because of that strong temperature gradient, thermal wind considerations say that you must have a stronger wind at altitude. So the jet stream is typically found a little bit to the north of both the cold front and the warm front, but it does parallel the fronts. And this is the jet stream at 300 millibars. So that gives you a little bit of the characteristics and the climatology of jet streams. And we'll start talking about the dynamics of jet streams in our next video.